This recycling system has been in place for the last billion years. I fit into it, you fit into it, and 100 years tops, my body can return to the Earth with no pre-processing. Yet that packaging I got in the mail yesterday is going to last for thousands of years, right? This is crazy. But nature provides us with a really good model here. When a tree's done using its leaves, its solar collectors, these amazing molecular photon capturing devices at the end of a season, it doesn't pack them up, take them to the leaf reprocessing center, and have them melted down to form new leaves. It just drops them the shortest distance possible to the forest floor, where they're actually upcycled into next year's topsoil. And this gets us back to the mushrooms. Because in nature, mushrooms are the recycling system. And what we've discovered is that by using a part of the mushroom you've probably never seen, analogous to its root structure, it's called mycelium, we can actually grow materials with many of the same properties of conventional synthetics. Now, mycelium is an amazing material because it's a self-assembling material that actually takes things we would consider waste, things like seed husks or woody biomass, and can transform them into a chitinous polymer, which you can form into almost any shape. In our process, we basically use it as a glue. And by using mycelium as a glue, you can mold things just like you do in the plastic industry. And you can create materials with many different properties. Materials that are insulating, fire-resistant, moisture-resistant, vapor-resistant, materials that can absorb impacts, that can absorb acoustical impacts. But these materials are grown from agricultural byproducts, not made out of petroleum. And because they're made of natural materials, they're 100% compostable in your own backyard. So I'd like to share with you the 4 basic steps required to make these materials. The first is selecting a feedstock, preferably something that's regional, that's in your area, right? Local manufacturing. The next is actually taking this feedstock and putting in a tool, physically filling an enclosure, a mold, in whatever shape you want to get. Then, you actually grow the mycelium through these particles, and that's where the magic happens, because the organism is doing the work in this process, not the equipment. The final step is, of course, the product, whether it's a packaging material, a tabletop, or a building block. Our vision is local manufacturing, like the local food movement for production. So we've created formulations for all around the world using regional byproducts. If you're in China, you might use a rice husk or cottonseed hull. If you're in Northern Europe or North America, you can use things like buckwheat husks or oat hulls. We then process these husks with some basic equipment, and I want to share with you a quick video from our facility that gives you a sense of how this looks at scale. So what you're seeing here is actually cotton hulls from Texas in this case. It's a waste product. And what they're doing in our equipment is going through a continuous system which cleans, cooks, cools, and pasteurizes these materials while also continuously inoculating them with our mycelium. This gives us a continuous stream of material that we can put into almost any shape, though today we're